Morning, everyone. My name is Limas. I work as a DevOps engineer at a company called Oxylabs. It's an honor to be here. Thanks to the Ceph community for inviting. And today I'm going to be talking how we can repurpose the Ceph Cloud-S3 module to achieve internal bucket transfers. So it's going to be an easy presentation, very good for the morning until the coffee kicks in. So first and foremost, what is Oxylabs? What do we do? So we focus on open source web scraping on various web intelligence gathering. We provide methods and technologies to achieve that, like proxies, API solutions, and we generate a lot of data sets for text, images, audio, and video most recently. We're headquartered in Vilnius, Lithuania, about 500 people. We often give out data sets for research, for various PhDs. So yeah, and how do we achieve that? Well, we have a huge technology landscape. So we use a bunch of tech. And the idea here is not to boast that, look at us, we use a bunch of fancy tech. The idea is that if you work in a field of DevOps engineering, infrastructure engineering, platform engineering, the scope becomes very, very big, which is going to be quite important later throughout the talk. However, at the very center of these technologies, we use Ceph. And in short, how does Ceph work with web scraping? Well, basically, you kind of separate the compute layer and the storage layer. And the compute layer is usually kind of like a bare metal Kubernetes cluster, which do the web scraping itself. So you have a bunch of development, a bunch of engineering there, and Ceph provides the RBD for persistent volumes on the Kubernetes clusters. Then once you have the data, text, images, what kind of data you imagine, you store it in various database solutions, usually Ceph itself, sometimes things like MySQL, Couchbase, and stuff like that. And you manipulate this data with other Kubernetes clusters, which also are backed by the Ceph RBD. Once you get that, you kind of have some kind of data set, which is once again stored in Ceph, and you kind of expose it to the clients through the file system or more recently the S3. So our Ceph usage story starts about like 5 years ago, maybe a bit more. It started with an easy way to have a RBD solution for multiple Kubernetes clusters. It quickly grew to using the Ceph file system for kind of developers to have a shared storage among the teams. Ultimately, it ended up with the Ceph file system to actually upload the data sets and expose it to the clients. And about 2 years ago, we had a 4 petabyte Ceph cluster. It's not as big as some giants Ceph users, but we're proud of it. And about 2 years ago, we had like a paradigm shift. So we introduced a thing called the data platform, which was focused on the Rados gateway, using things like iceberg table formats, Trino engines, DBT engines, Spark engines, and stuff like that. So we quickly started using both the Ceph file system and the Rados gateway. And throughout like 2 years, we doubled the size of our cluster. We had to rebuild it completely to bring it to like an internal network, racks with Kubernetes and Ceph next to each other for good network throughput. And we're looking forward at Oxylabs to introduce private cloud solutions with a bunch of virtualization technologies to maybe next year. So this is our cluster, just to show off. It's we just surpassed 1 billion objects. It runs about 380 OSD disks. We keep the costs low, so we run spinning disks. 3 times replication, quite a classic setup. We keep it at 80%. Just not to pay for empty storage too much. And if we look at how much we use, we always have this contest, which one takes up more space? Is it the S3 storage or the file system storage? We don't even calculate the RBDs because every single Kubernetes cluster has its own pool. We don't really care about that because it's just a few terabytes per cluster. So with this, we with the new with the new paradigm of the data platform, we faced one problem that I call the data exposure problem. So the idea is that we had the Ceph file system, which is exposed to the clients, and clients usually have a automated way of picking up the data sets that we expose to them. Some of the data sets can be uploaded to their storage, like S3 or Azure Blobs, but usually they have an automated way and they're kind of sticking to the file system. Oh, am I calling someone? Hey, welcome to the call. Oh yeah, they can. Yeah, sure. So, so basically, what happened with the new system? We build our data sets and upload it to the Rados gateway. While the clients couldn't actually take these data sets from us, we had to do a copy of these data sets to the file system. Just because of some of the clients just said, no, we're going to be using the file system. We're going to be using the old ways. We don't want to change anything. So while that was happening, we had this situation with some of the data sets that we actually did with the 3 times replication of the cluster. We had these data sets replicated 6 times. Given the fact that some of these data sets are actually just a derivative of another data set, you can imagine that you can reach even 12 times replication. And that costs us about like 200 terabytes of extra storage per month for quite a silly setup. So we couldn't stand in one place. We had to figure out a solution because we would be just running out of space or would have to expand the cluster endlessly. So what we did like an architectural decision. We introduced a tool called SFTP Go, which is an open source tool. I highly recommended it. It runs on Kubernetes. You can actually scale it. And we introduced lifecycle policies for expired data to actually move to other storage classes. We tried a couple of S3 mounts, but they proved to be a bit unreliable. They quickly consumed a lot of CPUs. They exhausted our servers, so we turned to something more scalable. And with SFTP Go, you could actually have virtual folders, access controls, and just point it to your Ceph cluster, to pools, and then use pools to take the data away to other storage classes. However, this brought one new problem. So anyone who's working with data, they know that sometimes data is partitioned by date, and we wanted our clients to use the latest data available. So for example, you push out some data to them, they pick it up after 3 or 4 months. We don't want them to be using all kind of data. Plus, we use storage classes to erase your coded pools or compressed pools. We don't want clients mingling with our erasure coded pools because it's just causing a lot of overhead in retrieving data. So we were facing one problem. The problem was that all of our obsolete and old data within the buckets that we're exposing to clients became visible while using storage classes. So an easy way would be just take and move the data away to some other buckets so it wouldn't be visible. However, remember the second slide I showed you? We had a bunch of tools lying around, and we said we don't want any more of those. It's just going to be a headache. It's going to be a tech debt in the future. We want to use whatever we have already in place. So that's when we decided to look at the Ceph Cloud-S3 module. So the Ceph Cloud-S3 module, it's an awesome piece of engineering. There is 2 Ceph blog articles written by Daniel and Anthony. I would highly recommend reading through those, but the main idea is that you have some kind of bucket, you have a lifecycle policy, and you can move the data between various pools. But in the end of the day, if you don't want to have the data lying in your cluster, maybe it's very expensive SSD pools or other pools, you can have an S3 endpoint that points to any other cluster outside. Maybe a tape solution, maybe AWS, maybe Glacier, anything that would move the data away from your cluster outside. So we decided to test this out. We read through the documentation, and we found one key thing which gave us a cool idea. So if you read the documentation, it says that the supported cloud providers are those that are compatible with AWS S3. And we thought, can we say that Ceph Rados Gateway is compatible with Ceph S3? Is that logical? Is that a correct assumption? And we said, let's try it out. So what we did an initial setup. So this is an example of how you can set this up. You first of all create some kind of compressed pool. here an example, I'm creating like an erasure coded pool. You can do a compression. You can actually skip this step altogether if you don't want to reduce any storage. And then you just do some placement targets, introducing like a new placement target and back it with an erasure coded pool or compressed pool. I gave it the name Bog just to follow the Ceph style standards because it's like an oceanic things, and Bog is something which doesn't move a lot, so we gave it that cool name. And that allows you to do one thing. You can actually create a bucket which is within some kind of reduced storage pool. The idea here is that in all of these cases, I'm not referring anywhere to outside cluster. I'm referring it to my own cluster. I'm just giving it a location constraint, and you can actually do everything through the Ceph dashboard. When you create a bucket, there is an advanced section. You can point it to a new placement with erasure coded pool or whatever other pool you use. Now, for the Cloud-S3 setup, it's quite trivial. You kind of introduce a new storage class. We titled, once again, Bog, although it's a bit different, but it's a storage class, and you type the tier that it's Cloud-S3. Now, the trick here is that at the endpoints where you actually would specify the AWS, you specify your own Rados gateway endpoint. It's very simple. It's kind of creating a situation where a snake eats its own tail, and you hope then for the best. One thing, like I'm just getting ahead a bit of myself, but one thing, you can keep the retain head object as false. Otherwise, you will have the metadata entries in your original bucket, and you will be not hiding it from any end users. So keep it as false so you wouldn't see anything. And once again, a reminder, we're here using a reduced storage pool. This is just a bucket created in the reduced storage pool. You can actually create it in the normal storage pools you have. That's not required. And then you just create a lifecycle policy. You add your own placement ID pool name and just give it a few days. And then you'll notice that the lifecycle transitions, they actually work, and they say that all your files are getting they're transitioned to a cloud endpoint. But we're actually tricking our cluster because the endpoint is back at the Ceph cluster itself. So here is an example with a more aggressive lifecycle policy. So we have a bucket which contains CSV, JSON-L, and Parquet files, a bunch of objects that take up a couple of gigabytes. And we have a target bucket which is set up as a storage class, and it's absolutely empty. And we give it just, for example, we give it just 1 day out for it to transition. All the objects there are actually tagged with the file type, the dump file type. And we also, just to keep it clean, we add the incomplete multi-part upload, just because that's a good, healthy practice for your cluster. And after 1 day, you can see that the original source bucket, it becomes empty because the CSV and JSON-L files expire naturally. And then you have a target bucket, which will contain your original buckets folder with all the Parquet files, all the objects, and all of the are stored as you just would expect. So with this, we can say that we solved our problem. We have a solution where all the obsolete data gets removed from your bucket, stored into an archive bucket. And the best thing about this, you don't have to use any third-party tools. So everything is done by Ceph internals through the lifecycle processing rules. And you can create actually a huge archive solution where you can move data between buckets, or you can actually just not use any compressed pools, not any erasure-coded pools, and you can have like a bunch of movement done, on the lifecycle basis. So that's cool, but we need to actually address some considerations for this to work. So the first and foremost is you need to adjust the Rados gateway lifecycle processing aggressiveness. So there are 2 configurations for the number of lifecycle processing workers and the worker threads. So one of them is for if you have a large number of buckets, another one if you have a large number of objects. So you usually need to increase them because you're going to be processing a bunch of data and you might not get everything transitioned in one go. The interesting thing is I had a huge discussion on the Ceph documentation with Anthony and I think it was Zach. We had to change, there was a typo where they said that you have to decrease these values and I have to prove them that you actually have to increase. So that was to show that like the Ceph community really needs proof if you're trying to change something in documentation. The second one is you have to know the Rados Gateway lifecycle processing hours. So the default is from midnight to 6 in the morning. And sometimes this might be not enough, especially for larger data sets. You need to adjust this. And this doesn't adjust that easily. You have to actually do restarts for the Rados Gateway daemons if you change this. So another solution would be maybe using the Rados Gateway admin LC process commands, but that kind of beats the point of the Ceph internals taking care of everything. The third one is just like a heads up. If you have target archive buckets and you expect the lifecycle processes to put data in them, you have to make sure that the multi-part upload cleanup, which is usually like a default for all the buckets, what people write down, you have to increase a bit this value because sometimes the lifecycle rules need more time, especially if you don't increase the aggressiveness, if you don't modify the processing hours. Sometimes you might get the multi-part uploads cleaned up and that will mess up a bunch of stuff for you, so be careful with that. And the fourth one is, it's not like a problem, but just to be aware that every single target bucket, if you create like an archive solution, it will be a storage class. So if you do like a zone group placement list, your tier targets will contain a list of all the target buckets. I hope there is no plans to create an API to list the storage classes in that sense because they contain all the keys, all the secret keys. So be careful with that. And I don't know if that's a very huge problem. So with that in mind, I hope this trick will help you in moving data without any third-party tools in your Ceph clusters. And yeah, thank you very much.